Have you ever wondered how electrical systems protect themselves from sudden surges or faults? The answer lies in a device called the circuit breaker. These crucial components act as vigilant guardians, stepping in to prevent damage or even disaster when things go awry. Today, we're going to focus on a classic in the world of circuit breakers, the oil circuit breaker. With a legacy steeped in electrical engineering history, these devices use oil as both an insulator and an extinguisher to squash electrical arcs in their tracks. They've stood the test of time, proving their worth in countless systems around the globe. But what makes them tick? How do they manage to keep electrical systems safe, even under intense pressure and high voltage conditions? Well, hold on to your hats because we're about to delve into the fascinating world of oil circuit breakers. Now let's delve into the details of one particular type of circuit breaker, the oil circuit breaker. So, how does an oil circuit breaker work? I'm glad you asked. Picture this, an electrical fault occurs, and the current surges. This surge of electricity races through the oil circuit breaker, reaching the contacts. The contacts, sensing the fault, begin to separate. As the contacts move apart, an electrical arc forms between them. This arc, a spectacular display of electricity jumping across the gap, generates intense heat. Now, this is where the oil comes into play. The oil, surrounding the contacts, absorbs this heat and transforms into a gas. This gas formation creates a kind of pressure wave within the breaker. The pressure wave rushes across the gap between the contacts, forcing the electrical arc into a space that's much tighter than before. This constriction, coupled with the cooling effect of the transforming oil, helps extinguish the arc. It's a bit like squeezing a balloon until it pops. Except in this case, the balloon is a dangerous electrical arc, and the hands doing the squeezing are the pressure waves from the oil. But the oil's job isn't over yet. After the arc is extinguished, the oil cools down and reverts back to its liquid state. By doing so, it re-insulates the contacts, preventing any further electrical discharge until the circuit breaker is reset. So, you see, oil in an oil circuit breaker is not just a passive bystander. It's an active participant in the whole process. It cools the contacts, extinguishes the arc, and re-insulates the contacts to prevent further discharge. It's the oil that enables the breaker to interrupt the fault current rapidly and effectively. Without the oil, the breaker would have a much harder time dealing with the electrical fault. The arc might not be extinguished quickly enough, leading to potential damage and danger. So as you can see, the oil plays a crucial role in the operation of these breakers. Now you might be wondering, why use oil in circuit breakers? What are the advantages? Well, oil circuit breakers hold a venerable spot in the world of electrical engineering, and for good reasons. They come with an array of benefits that make them reliable workhorses in the electrical world. First off, the oil in these breakers is a champ at arc quenching. When a fault occurs, the intense heat causes the oil to vaporize, creating a high-pressure arc that extinguishes the electrical current. This ensures a quick and reliable interruption of the current, effectively putting an end to any potential electrical fires. Oil circuit breakers also boast a high braking capacity. They can handle hefty levels of fault currents, making them suitable for systems with large power loads. Whether it's a power station or an industrial plant, these breakers can take the heat and keep things running smoothly. But it's not just about power, it's also about reliability. Oil circuit breakers are known for their durability. They can withstand a wide range of operating conditions and are less prone to failure compared to some other types of circuit breakers. They're like the trusty steeds of the electrical world. Maintenance, while necessary, is relatively straightforward. Regular checks and oil replacement can keep the breaker in good working condition, and in the long run, this maintenance can pay off. When properly maintained, oil circuit breakers can have a long service life, making them a cost-effective choice over the years. Finally, oil circuit breakers perform exceptionally well in high-voltage applications. Their design and properties make them particularly suited for such scenarios, allowing them to shine where others might falter. These benefits make oil circuit breakers a popular choice in many heavy-duty and high-voltage applications. While they do come with some downsides, their advantages are significant, ensuring their continued presence in the field of electrical engineering. So, the next time you come across an oil circuit breaker, you'll know just why they've stood the test of time. However, like any technology, oil circuit breakers have their downsides too. First and foremost, the environmental impact. The oil used in these breakers can be a source of pollution if not handled and disposed of properly. As we become increasingly aware of our environmental footprint, this concern is not to be taken lightly. The pursuit of more eco-friendly alternatives has led to the development of other circuit breaker technologies that are less harmful to our planet. Next, let's talk about maintenance. Sure, the maintenance is relatively straightforward, but it's still a necessity. Regular checks, oil replacements, and occasional part replacements are required to ensure these breakers perform at their best. This regular upkeep can add to the overall cost of ownership and may be seen as a disadvantage, especially when compared to newer technologies that require less maintenance. A third downside is the potential fire hazard. In the event of a severe fault, the oil can catch fire. While the breaker's design aims to contain such incidents, the risk of fire remains a concern. This safety issue has prompted the exploration of alternative substances for use in circuit breakers that are more resistant to fire. Another disadvantage is their size and weight. Oil circuit breakers tend to be larger and heavier compared to some of the newer technologies on the market. This can be a limitation, particularly in applications where space and weight are critical factors. Lastly, we have the complex installation process. Installing oil circuit breakers can be more complex compared to some modern alternatives. The need for oil handling systems and specific setup requirements can make the installation process a bit daunting, especially for those new to the field. Despite these drawbacks, oil circuit breakers continue to be used in many applications, thanks to their strengths. While they may not be perfect, they have proven their worth in the world of electrical engineering time and time again. So, we've seen the good and the bad of oil circuit breakers. They've certainly made their mark in the world of electrical engineering, offering effective arc quenching, high braking capacity, and reliability. Their long service life and excellent performance in high voltage applications have made them a go-to choice for many heavy-duty applications. However, every silver lining comes with a cloud. The environmental impact of the oil used, the maintenance requirements, the potential fire hazard, and their size and weight are factors that cannot be overlooked. These challenges have spurred the development of alternative technologies that aim to address these concerns. Yet, despite these drawbacks, oil circuit breakers continue to hold their ground in many areas, underlining their enduring relevance. In the end, the choice of circuit breaker depends on the specific requirements of the application. But one thing's for sure, the oil circuit breaker has made a significant contribution to electrical engineering.